Hello and welcome back to Codeblaze. And in this episode, we'll be continuing off from the last episode of the series project overview of Color Dash. And this episode, we'll be tackling Zenject. So, first of all, I want to get this out of the way that Zenject is probably an overkill for this project of this size. But my main objective here was to actually learn the library and get a feel of it and decide whether I'll be using it for my future projects and all. So if at the end of the series I'll create a video where I'll tell you about my experience of using Zenject and UniRX and what I think about them, what are the pros and cons. So do subscribe and you'll get to know when that video is up. Other than that, I'll be going over some basic Zenject, not the really what dependency injection and all that is. So if you want to get more information about that, you can check out. There are some great YouTube tutorials about Zenject and all on YouTube. You can just search for it. I'm assuming you have some basic knowledge about what dependency injection is and how it works. So I'll be discussing over that. So once you install Zenject, the first thing you do is at the top level you create your contexts. So contexts are basically your DI containers, and there are around 4 types of contexts that you can create. There's the project context, scene context, game object context, and there's one more that I'm forgetting about, but it's only the scene and game context that you'll be using most, and you can even just use one of them, like the scene context, and get away with it. Like you can see, I created a project context object, but it's pretty much empty and there's nothing to it. And you need to also be mindful of the initialization order, like the project context is initialized, then the scene and all, and then the game. So the scene context, like these contexts, you register your installers. So installers basically register your objects in the DI container, and you can create your different installers as and when required. So if you go to the rider, last time I went over the input system and you could see that there is this inject annotation, and there are many types of injections that you can do in Zenject. So the input system is using constructor injection. Since it's a class that I created, I could easily annotate the constructor with the inject annotation, and you should also try and use the constructor injection as much as possible. Obviously, you can't use it everywhere, especially when it comes to mono behaviors, because you won't be constructing them. So for cases where I need to inject into mono behaviors, I basically I use method injection. So I create a inject method and annotate it with the inject attribute. And that's how I get stuff into my objects, and how they are actually resolved is what happens in these installers. So this is some dead code that I was trying with the remote config, but couldn't get it to work. Like it did work, but not to my liking. So what do you have in installers? Also, you can have of different types. So you have the mono installers, which is the one you'll be using mostly. So mono installers are initialized as the game starts and you don't need to initialize them. And there are basic installers also that don't depend on any class. So they basically inherit an interface. So what you do with your installers is you override this install bindings method, and you have the access to the container. And you basically bind types, and you have many, there's all different types of functions that you can link and chain to bind objects to the container. So game colors is a scriptable object that I'm binding from the instance of the scriptable object that I'm getting, and you can mark them as singletons and all. So you can basically create a hierarchy of containers. You have a project level container, then a scene level container, then you have game object level containers. As you can see, I'm using the player installer. So stuff that is just used by the player, and some objects that are used only by the player are kept into a separate container. So that allows me to implement the facade pattern as quoted, as it was written in the Zenject's documentation. that basically allows on a higher level a better separation of concerns. So I won't be able to access objects that I shouldn't be able to access outside the player container. One thing that could be like, I don't have anything specific here fulfilling that case, but again, as I said, this was more about learning the library and the framework and getting a feel of it. So that's basically how the DI stuff is configured. So we'll take the example of our input system only, how the DI actually works. So in the player installer, I basically bind the input system as single. Since in the input system, I bind the input actions also and the input system also. So input actions class is generated for me. So I create a from method because I need some initialization on it, especially this enable function that needs to be called. And I bind this as a single and the input system type also as a single. Now these classes won't be initialized unless I request an object for them. So what happens is in my player class, so if we take a look at the inject method, I basically require the input system, which is basically my abstraction over the input actions that are generated by the new input map action, like whatever that package is called. So when the player mono behavior is initialized, this inject method is called by Zenject, and it basically resolves all the dependencies required by the player of mono behavior, and one of them would be our input, and that is when the input systems class will be initialized and its dependencies will be resolved. So this basically, it forms a tree and or what they call is a DI graph, and recursively the dependencies are resolved until you can finally get the object. So it all depends on when the DI graph is initialized. Even I don't know properly at what time Zenject initializes, but if we are looking at the singleton pattern, it's only when it's requested. But most probably if you have objects marked as single here, they are initialized at the start only when the object graph is created. That's what happens in .NET Core, most probably. So once we get the input object, so that basically using this injection, I can loosely couple the input system and the actual player. So once we get the input object, and since I'm exposing two UniRX streams observables from the input system, the left tap and right tap, I basically subscribe to them. So if you can see where else this input object is used. So I have this input handling section. So this setup input bindings is called in the start, and it basically, I subscribe to the input.left tap and input.right tap. And here is the power of UniRX coming. Like I can add these where clause. Suppose like right tap is for jumping. Now I should only be able to jump when the player is grounded. So using this where clause, I can easily put a expression here. Okay, you should check for whether it's grounded. And when this where clause is true, only then this subscribe rotate player function is called. Otherwise it won't be called. So this allows for a better flow. Like it's better to read it, and you get more control over it because you have many more operators with UniRX. That's why I feel like UniRX is really helpful if you're developing your game, because everything is happening in real time. But again, this isn't a video about UniRX. Yeah, I covered the basics of like some intro of UniRX in the previous video, so you can just watch that. So there are some other things also with the input Zenject. I'm sorry. So here I'm using the player installer. That means I'm using game object context. So if I look at the player object, I have this game object context script here. So basically I can register installers to this script. So the player installer is actually called by the game object context rather than scene context. So this basically allows me to like only expose objects that are required throughout the scene. That is only the player object. There are few objects that I'm not exposing. And Zenject provides you other many utility things also, like this Zenject binding script. So this way you can easily bind mono behavior directly. So you don't actually need to bind mono behaviors in installers here. You can use the Zenject binding component to bind any mono behavior to some context, or you can just like you can bind it to a game object context or the scene context as required. And the other thing about Zenject that I'm using is signals. So signals basically allow you to send events throughout. Like you can have subscribers to the signals and everything. And there's one more thing here, like the Zenject signals are actually compatible with UniRX, so you can. There's a flag you need to enable in the build settings so that you can convert the Zenject signal into an observable stream. So you can actually subscribe to Zenject signals, and I'm doing this game state update. So whether the game is in start or in play, pause, end. So this all comes from this game state signal that is provided by Zenject, and I take actions according to whatever happens. So you can see like the signal bus at itself is injected, and this get stream method basically converts it into an I observable, and I can subscribe to it. So this function is called whenever like the game state changes to any of these states. So this also allows me to loosely couples everything, and I can handle global level events like game state. So that's where the signal bus is intended to be used for. If you check the Zenject documentation, they also say like you can use UniRX for small and events that happen very much frequently, and they would go for signal bus for events that are more global level and happen less frequently. So some cases would be like player level up, or if you unlock something. So that stuff can be handled easily using the signal bus. So that's all that I have for Zenject here. So there are much more in detail you can go, because Zenject is a big framework and there's a lot more how I'm using here. The generation system which creates the platforms also uses Zenject, and I'll go over that when we take the topic of the generation and how I'm doing the procedural generation. So that's it for today. Please do leave a rating, and you have if any suggestions even regarding the code that I have created, because even I am learning and I would really like the feedback that I get from you. And subscribe for the next videos upcoming in the series, and do share it so that I can get as much feedback as possible, and even you and your friends can learn new stuff. Thanks. Bye.